Alright, so when we're solving absolute value problems, we have to start with the idea that the things inside the absolute values, if there's an equal sign between them, are either the same signs or they're opposite signs. For example, the absolute value of 5 and the absolute value of 5 are equal. In the same way, the absolute value of 7 and the absolute value of -7 are equal. Either the two things on the inside are the same, and when we take them out they're equal, or the things on the inside are opposite signs, and when I take them out to make them equal, I have to change one of the signs. So we're going to take these things out, say they're equal, or we're going to take them out and change one of the signs. And now it's just a matter of solving the equation with letters to the left, numbers to the right. Letters to the left, numbers to the right. So my solutions are 9 and 1. Again, the idea is either they're the same and I take them out and they're already equal, or they're opposites, and so when I take them out I have to change one of the signs to make them equal. Solve by factoring. Now you can use the quadratic formula to solve an equation, but on this problem I want you to show the factors. So we realize that our first term has to be either 2x and 1x, and our last term has to be 6 and 1 or 2 and 3 with opposite signs. So that means when I do the outsides and the insides, I'm going to subtract the absolute values. Well, let's try the 2x and the 1x. And let's try 6 and 1 with opposite signs. Or 2x and 1x with 6 and 1 reversed with opposite signs. And let's see if either of those gives me an 11. Remember, the middle comes from the outsides and the insides, so I have 2x minus 6x, and that's not 11. I have 12x minus 1x, and that's positive 11x, which is what I'm looking for. So those are the factors. And if they equal 0, that means that one of those two things is 0, positive 1/2 and -6. Solve a system for x and y. Lots of ways you can do it. You can do it by substitution or elimination. I'm always going to do it by elimination with a little method I call cross coefficients. My coefficients for y are 1 and -3. And if I swap those around, when I multiply, I get -3 and -3. So to make them zero out, I'm going to swap them around and change the sign on the bottom one. I'm going to swap them around and subtract the bottom one. I do that by changing the sign. So multiplying across, -6x, -3y equals -9. Multiplying across, -2x, positive 3y. Make sure you see why that's a positive 3y equals positive 5. And adding them down, I have -8x and 0 equals -4. To get the x by itself, I'm going to divide by the -8. And I get x is not 2, but 1/2. Using the same idea for the x coefficients, I have a 2 and a 2. You might see I have a 2 and a 2, so I'm going to swap them around and then subtract the bottom one, change the sign on the bottom, and multiplying across I get 4x plus 2y equals 6. Right here, multiplying across this way. And then multiplying this one across, I get -4x, positive 6y equals positive 10. Make sure you see why that's a positive. and you get 0. 8y is 16, and dividing by 8, I get y equals 2. Well, that's a fine answer, except the homework is going to want you to write that as a point, x and y. So your x point is 1/2, your y point is 2. I'm fine with these answers. The homework's going to want this as a point inside parentheses because you have an x and a y. Two equations with an equal sign. Pretty easy. All we're going to do is cross multiply. I'm going to multiply this one by 3 and this one by 4x minus 3. Let's do that again. I'm going to multiply this one by 3 and this one by 4x minus 3. We're going to cross multiply. Well, that gives me 9x minus 18 equals 8x minus 6. And now it's just a matter of letters to the left, numbers to the right. Gives me 1x equals 12. Now here's an interesting idea. If I ask you what number I could square to equal 49, you'd tell me 7, probably. However, there are two numbers. The thing inside could either be 7 or the thing inside could be -7, because when you square -7 you also get 49. The algebraic way of doing that is taking the square root, and that gives you positive or -7. Remember, when you take the square root, there are two answers. This symbol means the positive root, and the positive root of 25 is 5. But if I was given 25 and then took the square root, I would have to allow for both signs. So I'm given a square equals, and when I take the square root, I have to allow for both signs. Okay, letters to the left, numbers to the right. 2x equals 4. X is 2. Letters to the left, numbers to the right. 2x is -10. X is -5. That's a fine answer. You can write them like this if you would prefer. Homework's probably going to want it that way. However, do not put that in parentheses. It's not a point. It's not an x and a y. It's two x's. So do not put them in parentheses. It's not an x and a y. It's two x's. Alright, now the last one we took the square root because I already had a squared symbol. So in this next one, I've already got a square root, so instead of taking the square root, I'm going to square it. 3x plus 1 equals 49. In other words, what number could I have on the inside so that when I took the square root, I got 7? And the answer is 49. Here we go, letters to the left, numbers to the right. -1. 3x is 48. X is 16. Let's try another one. Alright, this one asks you to solve by writing as common basis to a power. Now, you don't see it on this sheet, but if you look above the board in my classroom, you'll discover that 32 is 2 to the 5th power, and that 128 is 2 to the 7th power. That's on the board above my wall. And since this one's being raised to the x power, I'm going to write that as the 5x, because you remember an exponent on an exponent, you multiply the exponents. Now it's a matter of simply canceling out the bases, dividing both sides by not 7, but dividing both sides by 5 gives me 7/5. Simplified. Now I've got this problem written twice. Once it's got a plus sign between it, and the other time it's got a minus sign between it. And when we treat them a little differently, I decided to put two examples up here to kind of show you how each is done. Of course, you have to remember how to FOIL out. Now you can FOIL that out if you want to. 5x minus 2, 5x minus 2. One of the shortcuts we teach in Algebra 2 is for squaring a binomial. It's really quick and easy. You just square the first term, and you square the last term, And when you do the outsides and the insides, you're going to have the same thing twice because I have the same factor twice. So I'm going to have a negative 10 on the outside and a negative 10 on the inside, which is going to give me a negative 20x in the middle. Let's do that one more time. Remember, when you FOIL a perfect square, you're going to have the first times first and the last times last, but your outsides and insides are going to be the same. You're going to have a negative 10 and a negative 10, which is negative 20x in the middle. Now, because I'm adding this next thing, I'm just going to write similar terms under similar terms. And simplify them. 28x squared minus 18x minus 3. Now, if I'd been subtracting instead of adding, I'd start off the same. First times first, last times last, negative 10, negative 10, negative 20x in the middle. But because I'm subtracting, I'm going to add a negative 3x squared, a negative 2x, and a positive 7. And add the similar terms. So those are two answers for two different problems. One had a plus, and I left everything with the signs exactly the same. Positive 3, positive 2, negative 7. One had a minus, so I changed the signs I was subtracting. That became a negative 3, a negative 2, and a positive 7. When do you change the signs? When you are subtracting. You add the opposites. Alright, I'm going to evaluate a formula if I plug a 3 in. The problem with this is I have a fraction. So when I plug a 3 in, that's going to give me 5 halves times 3 minus 7. Now I'm going to put that 7 over 1. Multiplying fractions is easy. You just multiply the top, you multiply the bottom. I've got to make this also be something over 2 because I want it as two fractions with a common denominator. So I'm going to say times 2 times 2, which makes that minus 14 over 2. And 15 over 2 minus 14 over 2 is 1 over 2. Let's do that again. It says write as the sum of two fractions with a common denominator and simplify. Do not use decimals or mixed numbers. When I plug a 3 in here, that's a 3 over 1, so that's going to be 15 over 2 minus 7 over 1. Now to make that be a common denominator, I'm going to say times 2 times 2, which becomes 15 over 2 minus 14 over 2, which is 1 over 2. Now if you type that in your calculator, you're going to get 3.5 minus, so you're going to get 7.5 minus 7 equals 0.5. And on your test paper, I'm going to do this and this because I want you to write it as the sum of two fractions with a common denominator. Let's do it one more time. I'm going to plug in a 3 over 1, and that becomes 15 over 2 minus 7. Now to find a common denominator of 2, I have to say times 2 times 2, which is 15 over 2 minus 14 over 2 is 1 over 2. Find the center and the radius of the circle with this equation. Now the center is a distance of 0, so I have to figure out what value of x makes minus 3 be 0, and that's a positive 3. What value of y makes plus 5 be 0, and that's a minus 5. And from the Pythagorean theorem, the x squared plus the y squared equals the radius squared. So if the radius squared is 144, then the radius is 12. Let's do that again. The distance of the center from itself is 0. So the value of x that makes minus 3 be 0 is positive 3. The value of y that makes plus 5 equals 0 is negative 5. And if the radius squared is 144, then the radius is 12. Finally, I have a formula, x minus 2 squared minus 2x plus 7, and I'm going to plug in a negative 2 and write that as simplified terms. Alright, so let's plug a negative 2 into each one. If I plug a negative 2 into here, that becomes negative 3 squared. If I plug a negative 2 into here, that becomes plus 4. It doesn't matter what I plug in, that's going to be plus 7. So my factors are 9, or my terms are 9 plus 4 plus 7 is 20. All I'm doing is plugging in a negative 2 and doing the arithmetic. One last time. Negative 2 gives me negative 3 squared, which is 9. Negative 2 times negative 2 gives me plus 4. It doesn't matter what I put in, there's no x's in that, that's just plain 7. When I add those together, I get 20. Now what happens on your test paper if you give me this and you write 20? I'm going to say wrong. First, write as the sum of simplified terms. I'm going to expect you to write that 9 plus 4 plus 7 equals 20. And that does it for us. I hope you enjoyed it. I hope this is helpful. Be sure and let me know if you need extra help, or go by the Center of Learning. Ms. Williams is there and she'll be happy to help you. These are the core to everything we're going to do for the rest of the year, so what you don't already know how to do, be sure and get help on.